we have Mr. Klaus Heinz, the founder of HEDD Audio.
Maybe best described by a series of an entertainer, of a Hollandish entertainer, Henry, and there was a show, it was dark, then there were two big horn speakers at both sides of the stage, and nothing happened besides a Schubert quartet was playing, The Death and the Girl, you know. And then he came onto the stage, and he went to the speaker, and was so astonished what kind of music there came out. The original being astounded by a loudspeaker representing music. And that's really a kind of interest that hasn't disappeared until now, no. And the first beginnings were ridiculous enough from today's point of view, of course. And as I spent so many decades with speakers and went to the scientific AES conventions and read the literature, and beside that I'm making music by myself, more the classical stuff, not what I find here. And so it came together with the music and this non-explicable interest. I may remind the following phrase from a famous physician who listened to one of those famous lectures of Heisenberg. He came out and told a friend, "I didn't understand anything, but I wanted." That's the way it started, you know, yeah. Take me up the linearizer idea because it is an ambiguous approach. That means in older books about loudspeakers, you could read that phase linearity is not audible, and there's a good mathematical explanation because you square it, then the time information theoretically has disappeared, or what arrives at your ear. And that was opinion true for 20, 30 years. And then a German guy made a PhD work that started those impulse response oriented phase correction. And in the beginning, it was even worse than without phase correction because the digital signal Verarbeitung, that means handling, was bad enough to overthrow the linearization of the phase response. But meanwhile, it is clearly audible. That is something many of you, I hope, have experienced, and that I found very interesting in the beginning because it actually is doing something better, no question. Whether it's audible or not had to be explored. And after having some good impressions, I put up some old classical recordings from Decca Tree, you know, that really made it with the orchestra. And there the difference was most audible because this is clearly runtime oriented stereophony. And there the phase response linearity really takes you a step forward. With the modern productions where you have your mixing console with all the tricks you have in it, the original localization and phase response disappears in importance at least. And so it is better, yes, sometimes more, sometimes less. And it was a missing link in speaker quality because it wasn't possible to really apply it before.
I think one of the, sort of at the other end, almost a low-tech innovation that's on the way would be material science, which is just developing lower weight, lower mass, higher rigidity materials that can do the same job that speakers have always done. The idea that gluing a magnet to the back of a piece of paper and making it wobble around in response to an alternating current, that's over a century old. But actually, amazingly, paper is still one of the best materials you can use for that. But people are starting to work with things like graphene for high-frequency drivers. Focal used beryllium. Actually, what Focal did was make beryllium usable in a way that doesn't immediately kill you. But the materials that are actually used, it's the interface between the electrical and the acoustic that I think some of the biggest leaps are still to be made, because loudspeakers are fundamentally they're steam. They're not even they're older than steam aged. Well, no, steam age technology basically.
May I more than agree, because in the former years, to chase diaphragm materials was the most important task for me, because all the rest, the coil and the magnet, that's like an air pump. That's easily to be handled. But the secrets of different diaphragms could be an extra session. And I totally agree, yes.
It's probably Class D technology and the integration of digital technology into speakers simply because of convenience. You know, we were talking about the problems of the room earlier and things like that. With new technology, whether it's a standalone room correction or built into the speaker, we've got so much more accessible technology now to really get around some of these inherent historical problems, you know, those horrible room modes which cause big bumps and things like that. They can be done pretty damn easily. They can be addressed with pretty damn easily now, you know. And so certainly in the field that I'm in the business of making things sound better, I absolutely embrace Class D and DSP technology. It just makes things so much easier.
The performance changes, and the materials used like 20 or 40 years ago are retiring, so to say. And there is I wondered a few times already about big tunnels and GBLs from like decades ago. You cannot expect to have the same performance. I wouldn't claim that for our speakers as well. That is the real truth. Yeah. It is not awful, you know, but it is audible, and 10 years, I think, is a fair amount of years to change the speakers. Yeah.
And are there things we can do to look after our speakers better and ensure that they have a longer life?
No. No, we fight for it. For example, if you take rubber surrounds, it's more safe. If you had those foam surrounds that were modern for some time, they are disappearing. They are getting in parts, you know.
The car industry does all right by offering, you know, I think in the EU and by extension the UK for the time being, 10 years after the discontinuation of a car, the manufacturer still has to provide parts for it. I think other industries survive by having these impositions placed upon them, you know, being user serviceable or
I would claim that
repairable.
A good rubber surround is not affected by 10 years, really. And I may add that with our tweeters that have a cupped-on folio that is used in airplanes to prevent fire and so on, that is a very, very stable, practically the most stable folio you can have. So I deny it for our tweeters due to the material used. And with the low end, we try to do really good rubber surrounds on it, because I'm familiar with the problem, and yeah, I don't want to have trouble after 10 years, not now in my age.
Well, there certainly are manufacturers who will still service 20 and 30-year-old speakers. I'm not actually sure what HEDD Audio's policy on that is, but
yeah.
it's not unknown.
Speakers are really different, and the more modern materials are really much better insofar. A paper cone has a natural 10-year problem. These are hexacone materials with Nomex, which really withstand the pains of time. So it is 10 years. A 10 years now question is quite different from a 10 years question 10 years before. So that is really has become better, and that's all I can say. I mean, so many materials are involved, so many glues are involved that the general remark is not possible. But the overall engineering quality of our speakers, as well as all the competitors, has improved an awful lot. And many details to be mentioned, from materials to glues to test methods, and it is really different from what I see in these big old guys that I sometimes see in the studios. It has become much better, promise, yeah.
Will there be further improvements in the future?
I'm not a prophet, you know. But what I can say is that speaker technology is so old and hasn't changed really, at least with respect to the voice coil systems, that I am confident that the material scientists or engineers, they work all the time, and progress is mainly made in materials. Big new ideas, after Oscar Heier's AMT, I cannot see or find. I would like to have one, I don't have one, and so I expect that the material borderline is what limits or makes new views possible, yeah.
If I can also add, this is from speaking to Phil Ward, who was supposed to be here today but wouldn't be. One of the things that he's mentioned from a commercial point of view. So when Klaus Heinz designs these speakers, he's not just doing it for fun. He's going, oh, there is a need for these high-end speakers. I will build them and people will buy them. And that commercial need can only be met if it's financially viable for people to build them. And one of the things that I've heard can be very beneficial in that is computer modelling. So you would take your composite material that you're making the cabinet out of and subject it to a lot of virtual tests and see, oh, there's a weak spot there, there's a resonance there, which means that you can do a huge amount of sort of pre-stress testing without having to make a prototype and a Mark 1 and a Mark 2 and a Mark 3 and a Mark 4. Which might be why we're seeing more high-tech monitors from a higher number of manufacturers rather than just a few manufacturers that have the R&D budget to build Mark 1, 2, 3, 4 before they achieve the sort of the pinnacle of a range.
And it depends from the big industry. If they came up with a new material like the Kapton folio, it really changed, at least for me, the situation. If new magnets are coming along, as they do at the moment, those neodyme special stuff invented in the United States, that might change as well. When I found the original Heil AMT, it was a big block with pole shoes and big magnets and not very practical. But for the audiophiles, it was a revelation, and it was one for me. I hadn't heard that good high-frequency reproduction before. But fortunately, the neodyme magnets came up at that point in time, and that enabled me to do this big block shrinking to a tweeter like the one you see in the middle here. So this was material progress and not an original idea. So again, if materials get better, and once again, so many big companies are working on different folios, on different kind of plastics that really find their way in here and there. The progress starts from there, and we are in an old-fashioned business. Speakers are working the way they have been invented like 120 to 150 years ago. Small progress in concept only, really. All the rest is materials and serious application of the materials. But the speaker itself, as mentioned, old stuff. Yeah.
One very interesting product that I saw demoed quite a long time ago now was some speakers which were invented by Drag Kolich, who's the main guy behind Audacy headphones. And he'd managed to create a planar magnetic full-range speaker, which was sort of desktop size like this. And I don't know what happened to them or whether they ever became a commercial product. Is that something you could do, for example, with the AMT in principle? Could you make a full-range speaker with it?
Yeah, but then I have to leave the dimensions I have here, you know. So and that was huge, and it was heavy, and it is nice for audiophiles, but it's not a broad application anymore possible. And so the same old restrictions remain the same. We are in the times of climate problems, right? And the worst machine around that you all use are loudspeakers, because the efficiency is like 2 to 3%. That would not fulfill any requirement of today's electrical machines. This limitation of 2 to 3% means they are slow, they are boring, they are really difficult to motivate to make good music in so far. It was nice, it was so nice if a speaker would came up with like 50 or 60% of efficiency. We approach the problem with big horn systems, as you do know. You can have 10 to maybe 12, 14% inefficiency, because of the horn loading, but still that is ridiculous compared to all other electrical machines, right?
But again, leaning into the fact that we are embracing more and more digital technology. So historically, Class A, B amps are the way, and still are for the large part, how we power a lot of, drive a lot of the speakers and produce the sound. But again, Class D digital technology isn't to be laughed at anymore. You know, it's not as naff as it was back in the 80s and 90s. It's got a bit of a stigma, or at least used to. But I think every other speaker brand has at least tried or completely fully embraced Class D, and so that's a whole different approach, right, in terms of crossover technology and amplifier technology. I mean, for one, it makes it really light for a start. But yeah, I would say, from my novice opinion, that it would be the Class D technology, and the way that we're driving the amps now has become much more efficient from the Class D technology. And then within that, the features that we can include, we can have fully parametric EQ built into it at no real extra cost apart from an extra processor, versus Class A and B was quite big and clunky and heavy and has its sonic characteristics and its attractions. But yeah, there's no denying how good Class D technology is making things for us.
Yeah, perhaps I may add that when I started these things, filters, crossover filters, were an issue of big discussion. Meanwhile, they're not anymore. Force order Linkwitz-Riley is the way to go. And if you have reasonable drive units, this filtering is okay. And it is not important even if you have a linear phase response. If you have a reasonable filter, which might still produce some phase, of course, some phase deviations, then you can totally compensate it if you measure the complete speakers without knowing who makes which contribution, which part of the speaker makes which contribution. You just see the result, you make a folding of the impulse response in the time domain, and then all these things disappear, measurable. There is no more phase response, the linear frequency response, other people can do as well, but this is an automatical success of the phase linearization process, or of the FIR filters that you can apply. So these things have practically disappeared as an object for engineering. And if you have reasonable crossover frequencies and reasonable drive units, then the dissipation, directivity of the speakers is rather optimized meanwhile as well. In earlier times, you had like a Christmas tree, right? Broad characteristic in the low end, getting smaller to the crossover point, getting broad again, and to the crossover point again. So for a three-way system, you had a nice tree there that was well known, of course. And today's good designs can avoid that. The best guys insofar are the Klein and Hummel speakers, which have a very linear directivity versus frequency response. But everybody can do it if he watches at the important points. There's no more secrets.
Sorry, just to add, so you've talked about how Class D amplification and DSP are already incredibly efficient and incredibly advanced, and we've already talked about how inefficient the copper coils glued to the back of a piece of paper are. But there was a technology I was reading about I forget who asked the question, it was someone at the back there. There was a technology I was reading about just on the train, just sort of swatting up on, which is current sensing. It isn't to do with efficiency, but it is to do with accuracy. And it's not even new, it's from 1989 or something. So in a bog standard loudspeaker, voltage goes in, you pipe it through the voice coil in the back of the speaker, and the voice coil moves in response. But the voice coil also heats up as it moves, and it has this current going through it. And current sensing, which is apparently it's woefully underused. It's a brilliant technology, but it's not used very often. Essentially, you measure the current going through the voice coil, and, if you like, compare it to the input current, or rather, yes, compare it to the input current, if you like, and it means that no matter how hot the voice coil is, the current going through the voice coil will be enough to move the speaker the right amount in relation to the input signal, which essentially eliminates thermal compression, or negates thermal compression, which is one of the big issues when you've got a speaker running for a very long time. Obviously, it gets hotter and hotter and hotter, and it becomes the excursion becomes less for a given input signal. So yeah, Google it. Current drive, I think it's called, and it's in an AES paper in 1989. I think for large scale stuff, when you really want to fill a room with lovely bass, fidelity isn't always the best thing. So I think if I was off my tits and dancing to jungle, so I wouldn't want to
Perish
listen
the
to these.
thought, Chris.
I'd want to listen to a big stack of bandpass woofers or W-bins or some function one stuff. I think what humans find enjoyable to listen to isn't necessarily the same as what's accurate and highly faithful to the input signal. So I think that they're just two different listening experiences where they don't necessarily have to learn from each other. If there was such a thing as a perfect speaker, there'd only be one kind of speaker. But there's a rig system, and there's a small sound system rig with wedge speakers firing into a small space where you get a lot of resonance. And then there's linear phase perfect things which measure in an anechoic chamber absolutely perfectly with 10 degrees phase shift, 20 hertz to 20 kilohertz. It's two kettles of fish, I think. That's just my thoughts, but. Please.
May I add a personal remark to that? When I started the whole thing and got a little, then I visited all good speaker designers in the world, like 5. One of them was Paul Klipsch, in Hope, Arkansas, that I visited, and where I tried to discuss with him the disadvantages of his loudspeakers. The advantages are plain on the table, and especially they are a kind of invitation to come back to the previous discussion. If we would have something with those 15% of efficiency without the horn problems, here I am. Let me know. With the normal speakers, you can't have it. So the advantage of the efficiency, if you have Billy Cobham with a drum solo, you know what I'm talking about, right? But the disadvantages of the early reflections of the horn are apparent with classical music. It is not right, whatever detailed discussion we will have, it is not right. And so for a universal speaker approach that serves all communities, it is not viable.
Yeah, there's always plenty of obstructions and limitations when you come to treating a space, and the cloud or the absorption above the mix position is often one of them, whether it's in a rented rented accommodation and you can't drill holes in the ceiling, or if you've just got exposed pipework or something like that, and it's just not realistic. And there's not really much you can do unless you can build a gantry or something where it's going to support the clouds. Now, yeah, I mean, a lot about treating the room, and certainly the spaces that I focus on, as I said before, it's, you've got to make compromises somewhere, Now, we were talking about clouds overhead, the absorbers overhead are a key place for early reflections, but there's plenty of early reflections on the left and right as well. Yeah? So you can still go a long way and make huge gains by just treating your sidewalls. It would be great to put a cloud up there. There's plenty of scenarios where we don't have the real estate to put bass traps in the corner either. But, bass traps don't necessarily have to go in the corner. Go thick enough on the rear wall, you're going to go a long way to do that.
Maybe it's the moment to mention a limitation of all monitors or loudspeakers. Compared to the task to reproduce a violin, there have been measurements about the directivity of violins from tone to tone. They are so different, you wouldn't believe it if you would see the diagrams. That means this dispersion into the room is one of the sensations in the violin, while it sounds so special. Nothing that gets totally lost with your poor recording engineers, you don't get it into the file, And then to limit the reflections of the room makes sense. We don't want to hear the room, we want to hear the recording, but still spatial information in many ways is totally cut off from the original musical events, as you do. You may have experienced that as well, of course, yeah. They are fraudulent insofar, those cardioid loudspeakers. We talk about the full frequency range, do we? Okay. Because the spatial impression you get, of course, is the room you are in. It's not the recording room. And so it is questionable for a real monitoring task. You get different, additional difficulties, but you may enjoy it. So you decide. For monitors, it cannot be a good solution from my personal opinion, no.
I'd differ there. Sorry, Klaus. But, I would differ, actually, and I'd say the less extraneous low-frequency energy your monitors are throwing away from you and then back into everything that comes behind a monitor and then gets thrown back into the mix with everything that's coming out in front is going to muddy waters. So by anything a monitor manufacturer, whether it's Gaitain, who do it passively, I think, with sort of tuned ports on the side, or Key Audio, who do it actively with filtering and side-mounted woofers. Anything you can do to negate energy leaving the back of the speaker and then joining the soup out the front is going to make the front firing sound better, I think, intuitively.
That's an ideal moment in time to make a remark about our subwoofers, because we take up this problem. So the HEDD subwoofers have an analog output for the satellites, but this one is delayed, like 10 or 20, 30 seconds, milliseconds, whatever you have in the back that you have chosen from the subwoofer. And so the phase response between subwoofers and satellites, which normally is lost, and which is the main cause for the bad sound of most of the satellite systems, that is compensated for. It's not forced back, but at least it's with respect to the subwoofers, it does solve the problem.
I mean, just to share how I calibrate subs, the first thing I will do is find the best position of the sub in, say, that front plane, if you like. And you do need some test equipment to be able to measure the phase of the sub, but also relative to one of the speakers, because that's how phase works. And get that in the very best position you can within the limitations. So you might not be able to put your sub in certain places, but within the space that you do, put the sub in different positions, compare the phase correlation to, say, your left or right or center speaker, for example, and get it as close as you can, and then just adjust the phase just to kind of marry them up as well as possible.
Plus minus only, right? Plus minus only.
Yeah.
And as I have to admit, if you do a real live monitoring, then that's poison, because you have like 20, 30 milliseconds in delay, and you get crazy if you have the original signal and a 20 milliseconds delay. Not pleasing, no.